What's up, guys? In this video, we continue development of our PIC16 based real-time scheduler that mimics RTOS functionality. And in this video, what I'm going to do is show you the improvements I made to the message queue. So we have the message queue, and basically what I'm going to do is I wanted to provide some conditions or functions to handle when the queue is full, when the queue has overflowed, and the queue is empty. So nothing really changes in the queue. We're still implementing our circular buffer system. The queue size is still 100. But the enqueue and dequeue functions is where we implemented these changes. So what we did is, in the queue, we added a conc to track the current number of elements. And when we initialize the message queue, we initialize this conc to 0. Now, when we put the enqueue, what the enqueue does is that if the queue is full, well, we have the function for us to check to see if the queue is full. And the way we do that is, once the count of the queue is equal to the size of the queue, which is 100, we know that the queue is full. And if the queue is full, we will do some error handling. I didn't really implement any error handling. Probably could, have an LED flashing, or you could provide some sort of error handling system in place and to send a signal to that global error handling structure. Maybe that's something I could look at developing, like a global error handling structure for our scheduler. And the dequeue system will do error handling for if the queue is empty. There's an underflow. That we are accounting for both overflow and underflow conditions in the queue. And now, when the queue is empty, instead of comparing the head and tail, what we do is we just check the count. So we could just check and see if the queue is empty to determine if the count of the queue is 0 to determine that the queue is empty. And the functionality for doing everything is basically the same. We didn't really have any change. We initialize our message queue, and the way the tasks implement the queue is the same. So that's it. Thanks for watching, and I hope this video was helpful in helping you see how you could implement a message queue system for microcontroller, a resource constrained 8-bit microcontroller. And in the next video, I'll probably look at improving the queue even more, probably adding error handling, global error handling system, so you can handle errors that occur